Okay, so section 3.1 is all about quadratic functions. Quadratic means that we have a degree 2 function. So that's usually of the form f of x equals ax squared plus bx plus c, where a is not equal to 0. And a has to not be equal to 0, because if it were equal to 0, we'd lose our quadratic term, and we would just have a line instead of a parabola. Okay, so the graph is called a parabola, and it is shaped like a letter U. All parabolas are symmetric with respect to a line called the axis of symmetry. And what this means is that if you folded the parabola in half along this line, it would be exactly the same on both sides. And the point where the axis intersects the parabola is called the vertex. And all of these terms can be a little bit confusing if we don't have something to look at while we're labeling them. So let's take a look here. So here you see that we have a parabola. Okay, so this U-shaped graph is a parabola. The point highlighted here is the vertex. And if you notice, that's where the dashed line and the parabola intersect. So the dashed line there is our axis of symmetry. So this is f of x equals a squared plus bx plus c, where a is greater than 0. So think about this. When a is greater than 0, or a is positive, we have a parabola that opens upward. Okay, so it opens upward. And because it's opening upward, it's actually giving us a minimum value. So we have our vertex here is a minimum. And the minimum is actually the y value of your vertex. So this makes sense because as our parabola opens upward, we have this point at the bottom that is the lowest point that we have as far as our y-axis goes. So all of our y values are above that, making that the smallest or the minimum value that we have. So here we have a look at a parabola that is kind of flipped over. So this, again, we have our vertex. And this is what happens when a is less than 0. So when a is negative. And when a is negative, the parabola opens downward. So in that case, our vertex is a maximum value. And again, that is the y value. Right, so we can represent quadratic functions as f of x equals ax squared plus bx plus c. However, the standard form, which is also known as the vertex form, is f of x equals a times the quantity x minus h squared plus k. And in this particular form, we can actually gather a lot of information about the graph of the parabola. So hk is our vertex. So this is the location of our minimum or maximum value. H also describes the horizontal shift of the graph. So that describes whether we're taking that graph and we're moving it like to the left or the right. And if h is positive, so h is greater than 0, you are moving to the right. And if h is less than 0, you move to the left. But it's very important in this case to note that you actually have a minus as part of the formula. So it's kind of going to appear that you're doing the opposite thing. Because like if you subtract a negative, it's actually going to look like x plus h in those parentheses. So k is the vertical shift. So you can also move the parabola up or down, and by ever how many units you do that is noted by k. So naturally here, as k is positive, you're going to go upwards, and if k is negative, you're going to go down. And a, that value of a in the beginning of the expression here does a lot of different things. So a kind of dictates the width of your parabola. So when a is 1, you have your normal parabola. If the absolute value of a is greater than 1, so looking at 2 or 7 or 10, you actually have a skinnier parabola. And so it's actually compressing that. And if you're you can stretch it by having an absolute value of a that is greater than 0 and less than 1. So if you have a fraction between those. And that's actually going to get you a wider graph. So really our compression, imagine that you have your parabola here, and we're going to push from the sides, and it's actually going to make your parabola skinnier. And the stretch is going to make your parabola wider. If it reflects, so if a is less than 0, or if a is negative, it's going to reflect about the x-axis. And that should make sense because in the last video, we saw that the parabola opened downward. So it kind of flipped there. So we have a reflection. In this video, we will look at rewriting the quadratic function into the standard or vertex form. So our goal here is to get this in the form of f of x equals a times the quantity x minus h squared plus k. The first thing we will do is factor, let me zoom in a little bit here. So the first thing we'll do is factor the first two terms. So our goal is to use completing the square to create a perfect square here. And out of this, I can factor a 2 because we have to have a leading coefficient of 1 in order to complete the square. So this will become 2 x squared plus 4x, I'm going to leave a little space there, plus 7. Then we need to calculate what is going to complete this square. And if you recall, that's taking your b term, which here is 4, dividing it by 2, which gives us 2, and then squaring that term, which is giving us 4. So in here we need to add 4. But we're not really adding 4. We're adding 2 times 4 because of that 2 on the outside. So we need to undo that or subtract 8. And remember, we're subtracting 8 because we're really taking 2 times the 4 that's inside. So we need to subtract 8 because 2 times 4 is 8. So we can now continue with our problem here. The 2 stays outside. We factor inside, and this factors as x plus 2, which is then squared. And 7 minus 8 is negative 1. So in our standard form, we have f of x equals 2 times the quantity x plus 2 squared minus 1. And this is actually telling us a good bit about our function. We know that the vertex is at -2, -1. We also can tell by substituting in 0 for x that the y-intercept is at 0, -1. So we can get a good bit of information from this particular format. Let's take a look at a few more examples. So number 2, we have f of x equals -2x squared plus 4. Here, all we want to do is factor out that 2. But I'm going to factor out a -2 because remember, we want to have a positive x squared. So when we factor out the -2, we're going to have a positive x squared minus 4x. And because we're not adding anything, any constant in the original, we don't need to have anything outside at the moment. So now we need to determine what we are going to add. So we'll have 4 over 2 is 2. Well, this is -4, so -2. And then -2 squared is a positive 4. So in here we're going to add 4. However, we would have to distribute this -2 to this positive 4, which in reality is giving us a -8. So we just put in there -8. So what we need to do here is add 8. Add 8 to the outside because we subtracted inside because we have that -2 out there. So then we can factor just like we factored up above. So we'll keep our f of x equals -2. We factor our quantity. Here it's going to be x minus 2 squared and then plus 8 because we have nothing to simplify that with. So again, this tells us a lot of information. Our vertex here would be something like, well, it would be 2, 8. So let's take a look at one last example here. In example 3, we have f of x equals -x squared minus 4x plus 1. So here we can use completing the square again. Remember that we have to have a positive x squared, so we're going to factor out a -1. So we get x squared plus 4x, and then our plus 1 on the outside. We go through all this work again, and this is the same work that we would have done in example 1 to get what we should add. So we take 4 because that's our b term, divide that by 2 because we want half of it. And that would be 2, and 2 squared is 4. So inside here I'm going to add 4, but we need to think about what we've really done. Because we have a -1 times a positive 4, we've really put in there a -4. So on the outside, we actually do need to add 4. And then we can factor as we have in the previous examples. Okay, so this is going to be negative x plus 2 squared plus 5. And again, we can use this to determine our vertex and any other points that we need to determine. So in this part, we're going to look at finding the vertex and x and y intercepts of a parabola. So here we'll look at two methods to find the vertex of f of x equals negative x squared plus 6x minus 8. So method 1 is to rewrite this in standard form. This is what we did in the previous 3 examples. So we'll go ahead and do that again. So we get f of x equals, we need to factor out a negative from the first 2 terms. So we get x squared minus 6x, and then our minus 8 stays outside. We take negative 6 divided by 2 and get negative 3. We take negative 3 and square it, and we get positive 9. So inside here I'm adding a positive 9. But we need to look at what have we multiplied that positive 9 by, and it's a negative. So really that's a negative 9. So we're going to go ahead and add 9 on the outside because we need to undo that. So here we have negative. We can factor this, and it gives us x minus 3 squared. And then negative 8 plus 9 is positive 1. So your vertex here, remember, is HK, so your vertex is 3, 1. Your y-intercept, that's what happens when you substitute in 0. So 0 minus 3 is negative 3. Negative 3 squared is 9. But we have a negative out in front, so we have negative 9 plus 1 is negative 8. So we'd have 0, negative 8. And x-intercepts, you are looking for what makes this equal to 0. So we can solve for that. It's a little bit different of a solving process, so I'll work through this one with you. So we want our y value to be 0. So this is going to be equal to negative x minus 3 squared plus 1. If we subtract 1 from both sides, we get negative 1 equals negative x minus 3 squared. Divide both sides by negative 1. So now we have a positive 1 equals x minus 3 squared. We can take the square root. So we have plus or minus 1 equals the square root of x minus 3. So now, let me scroll over here so we have a little extra space. Now we have x minus 3 equals plus or minus 1. So in this case, we either have x equals, when we add 3 to both sides, 3 plus 1, or x equals 3 minus 1, so x equals 4, or x equals 2. So our x-intercepts are at 2, 0, and 4, 0. Okay. So the other method of finding your vertex, your y-intercepts are still pretty much the same. Usually that's c, and then your x-intercepts you want to factor and set everything equal to 0. But your y-intercepts have an alternate method. So we can take that original function that we were given, leave it so that that goes back up to the top there. so that we can see it. So we're taking that original function that we're given and asked to just use this process on it. So we have f of x equals negative x squared plus 6x minus 8. And this is good for things that don't factor. And sometimes it's just a little bit quicker to do. So we're going to take here this negative b over 2a. So negative 6, because we want the opposite of our b term, which is 6, over 2 times negative 1. Well, this gives us a negative 6 over negative 2, which when we simplify is positive 3. Then we can substitute that back into our equation. So we want to find f of 3, which means everywhere we had an x, we replace it with a 3. So this would be negative 9 plus 18 minus 8. Negative 9 plus 18 would be positive 9 minus 8, which gives us 1. So we've seen this before because this is telling us that our vertex is 3, 1, which is the same thing we were told about our vertex in the previous method when we solved that. So vertex up here is 3, 1. Vertex down here is 3, 1. So they'll get you to the same place 2 different ways. Okay, and it looks like I kind of jumped ahead here, and we already did our x and y intercepts up in example A. So this video is actually on something that's pretty cool. We can, given 2 points, one of which being the vertex, we can come up with the entire equation for a parabola. So I've given you here standard form. What we want to make sure here is that this is set equal to y. Because when we take a look at the information that we are given here, okay, we are given a vertex, which we know is always in the form of h, k. And we're given a point, and we know from many years ago that a point is in the form x, y. So we have 4 variables that we know the values to, and 1, 2, 3, 4, 5 variables in our equation. But if we can put in 4, then we'll only have 1 variable unknown, which is going to be the a. That's what we don't know. And we can solve for that. So what we need to do is substitute in our point values. So here we'll have in y equals, let me just write this again. So y equals a times x minus h squared plus k. So our y value in this particular case is 0. We do not know a. Our x value is 0. Our h value is 1, so 0 minus 1. And our k value is 2. So we can go ahead and solve this for a. So we'll have 0 equals a times 0 minus 1 is negative 1 squared plus 2. We can subtract 2. So we get negative 2 equals negative 1 squared is 1, so 1a. So a equals negative 2. The only thing left to do is rewrite this so that we use a, h, and k and not x and y. The goal here is that given any 2 points, one of which must be the vertex, we can come up with the equation for the line so that we can determine or generate any other points that are not the vertex that are on that line or that parabola. So here we'll just substitute everything back in. So we need to keep y as y. Oops. Might help if I don't choose a highlighter. Y as y. Our a is negative 2. X minus 1 squared plus 2. So this is our final answer as far as this example is concerned. Let's take a look at another one. So here you are given again h, k, x, and y. And we're going to substitute these into y equals a times x minus h squared plus k. So here we end up with 2 equals a times 1 minus negative 3 squared minus 2. And remember, whenever we subtract a negative, we're really adding. So this is going to be 2 equals a times 4 squared minus 2. We can add 2 to both sides. So 4 equals a times 16, because 4 times 4 is 16. Then we divide both sides by 16, and we get that a is 4 over 16, which simplifies to 1/4. We can then use this, and h and k, to rewrite our equation, or to write our equation. So we get y equals 1/4 times x plus 3 squared minus 2. And the plus 3 comes from just kind of skipping over that fact that we're subtracting a negative.